In this lesson today, we're going to be discussing how to make histograms to represent quantitative data. So in this lesson, we're going to talk about how to make histograms, interpret them, and compare two distributions with histograms. So the only vocab required is, the actual histogram, but we'll be using vocab from previous lessons, such as, his shapes of distributions, etc. All right, so we know from the previous lessons that we can make a dot plot or a stem plot, and that's used for displaying quantitative data, which are numerical data that can be averaged. However, these may not be as useful and can actually be tedious for developing for large data sets. So what we can do is we can group the data together, we can group nearby values and get a better picture of the distributions. And this is essentially what a histogram does. So for the histogram, it shows each interval as a bar, and the heights of the bars show the frequencies or relative frequencies of values in each interval. So notice that we're dealing with intervals as opposed to individual data values. This is because we're grouping the values together to make the interval. So for example, in this, we have a dot plot on the left side, and we have a histogram on the right side. And so this is the data for 220 eruptions of the Old Faithful geyser. And this was actually the example provided in that lesson for dot plots. So how do we make the histogram? So in order to make a histogram, you want to choose equal width intervals that span the entire data. So usually 5 intervals is a good idea for a minimum. So you want to have a minimum of 5 intervals or 5 bars for your histogram. Next, you want to make a table that shows the frequency or relative frequency of data values in each interval. And this is a special type of table. It's essentially a frequency table. However, it's called a grouped frequency table because we're looking at intervals. So the next step is to draw and label the axes, and then you want to scale the axes. When you scale the axes and you actually make the histogram, make sure that when you make the bars that you make them equal in width and that you leave no gaps. So basically the bars always touch in a histogram. For labeling the axes, make sure you put the name of the quantitative variable under the horizontal axis. Indicate that the graph shows frequency or relative frequency of data values in each interval. When you scale the axes, place equally spaced tick marks at its smallest value. Make sure you start at 0 on the vertical axis. Place equally spaced marks until you exceed the largest frequency. And then, of course, the last step when you make the bars is to draw them, ensuring that they're equal in width. And also make sure that the height of the bar corresponds to the actual frequency. Intervals that don't appear or with no data value should still be present in the graph and will appear as a bar of height 0. Alright, so let's look at an example. So the following table actually represents the data for 50 states, similar to what we did in the last lesson with the 50 states in DC. However, this time we're comparing the percent of foreign-born residents. So they want us to make a frequency histogram. So I went ahead and listed out the data numbers, so that way we're not dealing with the large table in the previous slide. So looking at the data, we want to make the histogram from this. So remember to choose equal width intervals that span the data. So from the data set above, notice that the smallest number is 1.3% and the largest number is 27.1%. So we're going to choose intervals of width 5 starting at 0. Again, you can choose your interval size yourself. However, make sure that you have enough intervals, minimum of 5, when you develop the histogram. So I'm going to choose from 0 to less than 5, from 5 to less than 10, and so on. So remember, I specify 0 to less than 5 because if I have the number 5, that doesn't belong to the first group, that actually belongs to the second group, and so on. This way there's no trouble in assigning which number belongs to which group. Now we're going to start making our table using these intervals. So this is known as a grouped frequency table. So here's the table below. So on the first column is interval, the second column is frequency. So we're going to go ahead and list the intervals that we developed in step 1. And now we're going to start counting the numbers that belong to each group or each interval. So if you look at the data set above, if we cross out all the numbers that are that are essentially between 0 and 4, because we want to be less than 5, then that's 19 numbers, and I crossed them out above. So 3.4, for instance, 4.3, 4.6, they all belong in this group. Crossing out the numbers between 5 and 9, because we don't want to include 10, we have 15 numbers. Crossing out the numbers between 10 to 14, so that we don't include 15, that gives us 9 numbers, and so on. 4 numbers for the next one, 2, and then 1. And that's our entire data set. Alright, so I went ahead and re-summarized and put that frequency table on the right side. So next we want to draw and label the axes. So we have the vertical and horizontal axis. Again, we got to label it. So the x-axis, we're going to label percent foreign-born residents. On the y-axis is the number of states, which is the frequency. Next up, we want to scale the axes. So the horizontal axis, we're going to make it from 0 to 30 with marks every 5 units. And we did 0 to 30 because that represents the interval. Alright, so now for the next part, the vertical axis, the highest frequency notice is 19 and the lowest is 1. So we're going to start from 0 to 20 and mark every 5 units. Now next we got to draw our bars. So for the first one, notice that it's between 0 and 5 for our first interval, and it's 19 for our height. Next one is 15, then 9, 4, and 1. Excuse me, so 2 and then 1. There you go. So we have our entire data set. All right. So your choice of intervals in a histogram can obviously affect the appearance of a distribution. So for example, on the left side is our original histogram with our interval of size 5. And the right side, if we halve the interval size and make the intervals 2.5 units wide, then we get this distribution. So obviously these two distributions look different. However, they're both skewed to the right, but the details are a little bit different. So keep in mind that when you're choosing the intervals, you can affect the actual shape of the distribution. So you want to make sure that you don't have too many intervals, but you don't want to have too few intervals. So therefore, that'll change your interval size. Let's look at another example. So this time we want to interpret the distribution from the histogram. So use a table from the previous example in the histograms to answer these questions. So what percent of states have less than 10% foreign-born residents? So if you go back to the table, we want less than 10%. So in that case, there were 19 people that were at the top, and then 2 people, and then 15 were in the second category. So in this case, we have the 19 here, and we have the 15 here. And these people were less than the 10%. So we went ahead and added them and then divided by the total of 50 states, which is 34 divided by 50, or 68%. Describe the shape of the two graphs. So we'll show the graphs here so we can reference them. So the left histogram is actually skewed to the right, and then with a single peak of from 0 to 5%. So there's a peak here, obviously, and then it's skewed to the right because this is the direction of the longer tail. Then for the right histogram, it's also skewed to the right. So we kind of draw that. It has a tail that is longer in that direction, so it is skewed to the right. However, there are 2 peaks, one in this general vicinity, one here, and there's also a gap here between the 22.5 and the 25%. So therefore, from this, it looks like there's that outlier because of that gap for California. All right, so this time we want to compare distributions with histograms. So we're going to look at developed histograms. So when comparing the distributions, remember it's a good idea to use relative frequencies when comparing, and this is because you're able to compare percents directly rather than individual counts. So use the same intervals when comparing histograms. So the graphs can be drawn using a common horizontal axis. All right, so let's look at an example of this. So here are the two histograms that we're actually comparing, and notice that they share the same vertical axis. Well, they actually share the same vertical axis scaling and everything, as well as the horizontal axis scaling. So therefore we can more efficiently compare these. So the question is it true that students who graduate from high school earn more money than students who do not graduate from high school? To find out, we took a random sample of 371 U.S. residents aged 18 and older from a recent census. The educational level and total personal income of each person was recorded. The following are relative frequency histograms of the data for the 57 non-graduates who answered no and the 314 graduates who answered yes. Compare the distributions. All right, so again, if we compare them using counts, it wouldn't make sense because we have 57 who said no and 314 that said yes. So therefore, it's more effective to use percents here. All right, so the solution. Let's talk about the shape. So both distributions are skewed to the right, as you can see, like this. There and there. So it's skewed in the right direction. Notice that they both have one peak as well. So now let's look at the center. The center of the distribution is larger for graduates than it is for non-graduates. So if you look at the graduates, the center is more, to the right than it is. So if since notice that we have a peak here, however, for the peak there, since this is more skewed to the right, the average is actually, more to the right than it is here. This is skewed to the right, but not as much because of these outliers. So therefore, the center here is more around here, and which is farther to the left than the graduates. Variability. So the incomes for graduates seem to vary a lot. So notice how wide this distribution is compared to this distribution, which is not very wide. And then outliers, as we mentioned earlier, there seems to be some high outliers for graduates. So we had some, quite successful graduates who actually made a decent income and a large amount of income relative to their other peers. All right, go ahead and pause the video and try the following example first. All right, so the table below gives the ages of the first 44 U.S. presidents when they took office. So we have a bunch of presidents and their ages when they took office. So the first step is to make a frequency histogram using intervals of width 4, starting at age 40. So I'm going to go ahead and actually display the data in this fashion so to save some room. So I went ahead and listed all the ages. Now we want to make a histogram, so we need to actually develop a grouped frequency table first. So what I'm doing is I know that my smallest number is in the 40s, and my largest number is in the 70s. So I'm going to break it down into these intervals, and I'm going to go by 4, which the problem says to start with an interval of 4 and start at age 40. All right, so now we're going to go ahead and cancel out the numbers between 40 and 43 for the first interval. So if you do that, there are only two numbers, 42 and 43. The next interval between 44 and 47, there are 4 numbers. The next interval between 48 and 51, there are 8 numbers. Next one between 52 and 56, there are 10 numbers. I'm sorry, between 52 and 55. For the next one, between 56 and 59, there are 8 numbers. 60 to 63, 5. 64 to 67, 3 numbers. And then last, 2 numbers. So now we can go ahead and develop the histogram. So on the y-axis, we have the frequency, which is the number of presidents in this example. On the x-axis, we have the interval, which is the age at the time of office. Right, so then we got to develop our scale. So I'm going to go, for the x-axis, you're always going to use the intervals that you developed, in your frequency tables. All right, and then for your frequency y-axis, I just went from 1 through 10 because the highest number here is 10, the lowest number is 2. So you always want to generally start at 0 for the y-axis. All right, so if we draw the bars from 40 to 44, we have 2 presidents. Between the ages of 44 to 48, we have 4 presidents. For 8 presidents, 10, 8, 5, 3, and 2. So looking at the shape, this actually looks roughly symmetric. So it almost looks like bell-shaped. So the shape is clearly roughly symmetric. More specifically, we call it bell-shaped or normal. All right, for the third part to the question, we want to add up we want to figure out all the presidents that are, in this case, going back to the original slide. What percent presidents took office before the age of 60? All right, so before the age of 60, we have this line here. We have to add up all of these presidents. So in that case, there's the 3, or there's the 2, 4, 8, 10, and 8 presidents that we need to add together. So we add those up together, and then we divide by the total number of presidents, and then times it by 100, and we get 72.7%. All right, so to summarize the lesson, we discussed histograms, but in addition to the dot plots and the stem plots, these histograms are useful for representing quantitative data. And the histogram is actually a common way of representing these quantitative data, especially when the size of the data set is large. We discussed how to actually make the histograms, how to determine the shape of and interpret them in the context of a problem. And we discussed how to compare distributions for histograms. All right, the next lesson we're going to discuss how to measure the center, which includes like average, mode, mean, etc.